Hello everybody. Let us look at this problem we are going to solve right now. The problem statement is a block of mass m and a pan of equal mass are connected by a string going over a smooth light wheel. Initially the system is at rest. If a particle of mass m strikes the pan with velocity u and sticks to it, find out the final velocity of the system just after the collision. We are going to solve it with two approaches. The first approach is going to solve is a lazy approach. आलसी लोग करते हैं. So this approach is collision approach. What is this approach? We'll try to conserve the momentum initial and the final. So what is the initial momentum? Before the particle hits this pan, what is the momentum? M into U. And what is the final momentum? If it sticks to it, the entire system, if it is moving with velocity v downward, this block will also move upward with velocity v upward. The total momentum of the system after the collision is 3 into m into v. And if the particle sticks to the pan, that means it is an inelastic collision. So initial momentum, final momentum we can conserve because no external force is acting. Then we can find out the final velocity of the system, v equal to u by 3. That is the method 1. Now we'll try to solve it with another method that is called the impulse method. What is this method or method 2? We'll try to see when the particle hits the pan, what happens at this moment. Particle is hitting the pan with velocity u. So when it sticks, it is getting some impulse in the upward direction because its velocity is getting reduced. Let us say this impulse is J1, and same amount of impulse will be given to the pan also as per Newton's third law. The impulse is J1. And as this string is connected over this pulley, the string will develop a tensile impulse. What is that impulse? Let's say the impulse is going to develop is J2, but it will be upward direction, right? Because the tension always acts outward from the body. So this is tensile impulse, it will also act outward from the body. And as the string is inextensible, the entire tension or tensile impulse is going to go and cross the pulley to the block mkg. That is also J2. Now we'll try to write the equations of motion. Now what is J1? See, let us say, this time also, let us say that the final velocity of the system is v. Then what is J1? For the particle, we'll try to write the equation of motion. What J1 is acting to the particle is upward. What J1 is doing? J1 is the impulse, that means it will change the momentum of the particle. So what is J1? J1 is equal to initial momentum mu minus m. Done. First equation is done. Now for the pan, we'll try to write the equation of motion. Not equation of motion directly, the equation of impulse is acting J2 upward and J1 downward due to the hit. So J1 minus J2 is change in the momentum, that is m into v. And secondly, J2 impulse is acting on the block on this other side, this block. This block, J2 is doing what? It is changing the momentum of the block, that is m into v. Now what we'll do? Three sets of equation we can write, and if we solve these three sets of equation, we'll just find out what is the velocity. Now we'll come here, this point. J1 will write mu minus mv. So first equation will put in the second equation. What is J1? Mu minus mv minus J2. Second equation, what else? J2 is how much? From third equation, we can write that equal to MB, and that is equal to MB. So we are writing the second equation from the first and third equation. So mu minus 2mv equal to mv. This will go to the right side and mu equal to 3mv. Then we are getting final. This is the method, yes, impulse method. I hope you understood both the methods, method 1 and method 2. Okay. Thank you. Have a nice day ahead.